Okay, so the purpose of this short video, and I will do my best to make it short, is to go over problems 7, 8, and 9. These three are a little bit tricky and do require you to use some trig. For problem 7, I recognized that the radius 12 can also be drawn to the other edge of the chord. Because the arc was 120, this angle up here was also 120. So here's a triangle that you have. A 12, and a 120, where this point up there is the center. I know that any segment drawn through the center is a perpendicular bisector of the chord. So if I do that here, I've created a 60, a 30, 60, 90 triangle. Let's see, what else do we know? Here's the x value. Because it's a 30, 60, 90, the hypotenuse is across from the 90. The shorter side has a length of 6, so the long has a length of 6 square root 3. We are trying to find the length of the chord, which is this whole bottom down here. It's this whole bottom one down here. So the whole hypotenuse was 12. The short side, let me draw this one more time here. The hypotenuse was 12. So the short side is across from the 30 is 6. And the side across from the 60 is 6 square root 3, which happens to be half of my chord. So if half of the chord is 6 square root 3, the other half of the chord is 6 square root 3. So my final answer is 12 square root 3. I think on the other video at the end it had a 12 there, or 24 there, but the correct answer is 12 square root 3. Letter B is very similar, that if we recognize a chord can cut through the center and be a perpendicular bisector, we're going to end up with a 90-degree angle here, but it's not a 30, 60, 90. Because this arc is 86, this interior angle is also 86. This makes a straight line. It's 180. So 180 minus that 86 ends up giving me hold on. What does it end up giving me? So it ends up giving me 94. So this measurement in here is 94 degrees, and we got that because it's supplementary to the 180 degrees, that straight line, and the 86 came from the arc. So we know that this angle here is 94 degrees. So we end up with a triangle. I'm going to cut through the center, cut the 94 in half, cut the 20 in half. So I end up with a triangle. Half of 94 is 47. This is 90. Half of the 20 is a 10. I'm trying to find x. Using the 47 degrees, I have opposite and I have hypotenuse. So I'm going to say the sine of 47 equals opposite over hypotenuse. When x is down low, switch them, you know. So x ends up equaling 10 divided by sine of 47. So 10 divided by the sine of 47 left me with 13.67, so we'll call it x equals 13.7. There was definitely nothing easy about this problem. If it doesn't make sense, please find me so that we can go over it. Most of your problems are considerably easier than this one. So check out number 9. Number 9 has a chord length of x, a radius of 6. So the other radius is 6. Using the same notion that the diameter creates a perpendicular bisector, actually, we don't even need that. Check this out. The central angle is 90. That's a 90-degree triangle. So look at it this way. That's 6. Those are both a radius. So that's 6. So I can find x without needing to split anything. 6 squared plus 6 squared equals x squared. 36 and 36 is 72. So when I square root that, it ends up being 6 square root 2, which you might have been able to assume if you were using 45/45/90s. I apologize about making this one, the first video, a little bit longer. These problems are challenging, so please let me know if you have any questions. Good luck.